What's going on, everybody? Welcome back to IT Security Labs. And if this is your first time here, my name is Howard, and I'm very excited to be sharing with you today more information security knowledge that I think is going to be very helpful for all of us. I believe in hands-on learning, less talking, but really getting your hands dirty, learning these technologies. I think that that's the best way to learn information security, and I'm going to share with you what I've been observing with the Log4j vulnerability. We're going to be exploiting a VMware VCenter appliance. This time it's going to be running in Windows. I made a video a few days ago where I attacked the one that runs in Linux, which is the future. The one that I'm going to be using today is actually going to be deprecated in the future, and it's just fun to attack Windows. That's why I like this one better. So we'll be attacking it in Windows, and we will use the SIEM solution here. This is the Elastic SIEM. If you want to set this one up for yourself, you can just go to elastic.com and sign up for a 7-day trial. So right now I'm just running this in the cloud right now. And after that, I have a VMware VCenter, VMware environment that's running. I installed the Elastic agent on that Windows system and is sending the logs to the cloud. So here's a vCenter environment right now. I can try to sign in here. This is what we'll be attacking. This single sign-on page, that ability, that's what we'll be looking for. And then we'll be detecting using the Elastic SIEM. In particular, we are looking for these alerts here. How do we know that alerts are firing? How do we detect? How does detection work? Getting our hands really dirty, digging through all this stuff is the best way to learn. You can watch a video of someone explaining how this works for 40 minutes, or you can watch someone actually do it and you can actually do it yourself. I think that doing it and seeing hands-on is going to be the best way. And as always, I'm just going to say here, this is for educational purposes only. I don't wish that someone will go out there, find vCenter servers on Shodan or anywhere else and do this. It's just for us to learn. So as you can see, I've already done some of it. I have a potential Java JNDI exploitation attempt. I had to set this one up. The Elastic SIEM does not come by default with this rule setup. So I'm going to show you how you're going to be able to do this. And James, it's good to see you. Orlando, Xroyd, and Abby, it's good to see everybody. Thanks for joining me. This is very, very exciting. In addition to that, I also have Security Onion. We cannot disregard Security Onion. And Security Onion here is also running. This is an intrusion detection system. That's the network part of things. Today, I'm mostly focused more on the host-based detection, where we have an Elastic agent. So first, before I get started here, let me show you how this is actually working. So if you go to elastic.com and sign up for a free trial, you need to enable fleet management. So if you go to fleet, I'll just show you quickly how this is set up so that you can easily set it up yourself. In fleet here, I registered a Windows machine. It's called whatever this name is. It says it's offline right now, but it's actually working. Thanks, Cybertech Dev. I really appreciate the feedback. Yeah, it says it's actually working. It says last activity 7 hours ago. Maybe I need to reboot this host here, but it's working right now. So you need to enroll your Windows machine to Elastic SIEM. This is host-based detection. It's very different from what we do every other Sunday or every Sunday, because every Sunday we do Security Onion, which is network-based intrusion detection. This is host-based detection. So once you enroll your agent here, you need to make sure that it's healthy. So let me go to my network. I need to make sure that this agent is actually checking in. It might be dormant right now. I might need to restart it. Then our workflow is going to be like this. We're going to attack the system. We'll get reverse shell as system. And as soon as we get a reverse shell as system, we'll come back here and look at, okay, what happened? How did we detect it? And how could we have detected it? And that's what we're going to be doing. All right, so looking here in my network, it seems like I'm getting data. Let me verify here. So this one was last seen 11 minutes ago. Okay, I'm going to bring up my host machine so that it can actually keep bringing all the alerts here. Then we will get started attacking it. In fact, let me make sure that this thing is checking in. It's really good to see everybody. Thanks for joining. Really appreciate everybody. Thank you for all the support. This just shows that, hands-on learning, there is no substitute for that. I have a bunch of certifications in IT, even in cybersecurity, like the OSCP and the CEH. Those certifications really don't mean much. What we're doing right here is really where the money is at. Being able to make sure that you can do what you actually are hired to do. Can you do it? The answer has to be yes or no. And can you learn it? Yes. If you show up with a ton of certifications, nothing against certifications because I have a ton of them, they're just useless. This is what we need to be doing. All right. So we now have our system is checking in. I'm looking at this last scene here. This shows me the last time that my system sent alerts. So think of this as, say, Windows Defender on a system, and it's sending all the logs to a central place where you can actually see the logs. And if you want to see what the logs look like, you can just, in Elastic, I will show you here quickly. This is all the logs that are coming from my Windows system right now. So we are logging host-based events using Filebit as part of the Elastic agent. Well, it looks like it's still loading. But we are logging here. So without wasting time, let's go and get started. If you are not familiar with Log4shell, here's a link for it. I will not be able to do justice explaining what Log4shell or Log4j is in detail because this is not what we're here for. In fact, I'm going to be attacking a system using Log4shell vulnerability, and I might not fully explain it to you. So that link that I put in the chat there is going to really help you make sure that you get a good understanding of what you are doing. So now that we have that link, make sure to read and understand how Log4j works, because just in case I don't do it justice explaining here, know that I did give you a resource to go to. All right, so now first I would like to go to my Kali Linux, and inside of my Kali Linux here, I have a VCenter directory and a Log4j scan. This Log4j scan here, it's a Log4j scanner that you can find on GitHub. So I downloaded a Log4j scanner because I wanted to see if we can actually just scan our system to see if we can get an idea of whether or not it's there. So here's an example. GitHub is plagued with a lot of these scanners. If you have any systems that you think might be vulnerable, go through GitHub, see which ones work. I have a Log4j scanner here, and this one will not tell you that your vCenter is vulnerable, and this is how an attacker would do it. They'll scan the internet, they'll go to Shodan, they will maybe, if they're already on your network, they'll run a scanner like this one, or their own custom one if they're smarter than me. And this is just a public repository where you can just run, and it will tell you if a system is vulnerable or not. So I installed it using the instructions on this GitHub repo. Then you can just run using Python after you install it. So we're going to run it against our vCenter server to see what does it look like. So I'll remove the URL here, and I'll replace that with one from my vCenter. So this is my vCenter login page. I didn't know which part of this it wants. I know the exploitable part is this for vCenter. So if anybody knows how to properly run this thing so that it can tell me that my vCenter is vulnerable, please let me know. But so far, when I run this scanner, it will go to my vCenter. It's actually trying to do a DNS. Now I know why. I know why it's not finding it. It's not finding it because it's trying to use DNS. vCenter is vulnerable to the LDAP. So I need to find an LDAP one. Anyway, I need a better scanner. So this scanner here was trying to call back for DNS queries. So of course it says the server is not vulnerable, but we know this vCenter is vulnerable. So that's what an attacker will do. They will scan it using the correct scanner, not DNS, but LDAP scanner. And then after scanning it, it will most likely say it's vulnerable. Sometimes they just go to Shodan using the Shodan API and find your vCenter laying out there. So make sure that you patch. But after an attacker scans something like this, what does that look like on the network, right? That's what we're interested in. Just a scanner. Forget the exploitation. They just scanned your network. Somehow they got on someone's computer as administrator and they are scanning your network. If you have a network intrusion detection system like Security Onion, you can go to the hunt section here and say, hey, by the way, give me any entry that you see that go to URI.keyword. In the URI, if you see JNDI or any of those indicators for Log4j, this is just my lazy way of saying I know there's JNDI in the URI and it will work. So let me cheat a little bit here. In order for me to be able to see this, I would like to force my network to see it. Instead of HTTPS, I'm going to send it in HTTP. This is going to fail because vCenter only likes HTTPS, but this is good for demonstration because if it's HTTP, I'll actually be able to see this request here. I would like to show you what a scan might look like. All right, so coming back here, I should have a couple, but here's one already that we might actually be able to look at. Okay, I lost everybody. Let me see. Okay, so here's one. So when we did the scanner, what you are looking for within the network traffic, which is where the money is at, being able to know what's going on the wire, is this one actually has HTTP proxied, and we're using the X forwarder. This is just a scanner, and it's testing what gets caught by most intrusion detection systems. And I'll be showing you Suricata rules here in a little bit, and you are going to see this pattern a lot when you're detecting Log4j. First is this JNDI part here. You want to make sure that whatever detection you're doing, you can include this. But this one is calling to LDAP. Usually there's DNS or LDAP or another service as well. But as you can see, it was actually forwarded. So this was X forwarder 4, which is what we'll be using today. And this is the referrer that we did. What you are looking at here is just on the wire, on the network, what does Security Onion see? Yes, I'll update Chrome. Chrome wants an update. What does Security Onion see? And so far, this is what it looks like on the wire. And being comfortable looking at this data, even though it looks like gibberish, is very, very valuable for us. We want to be able to tell. And so far, I looked at the user agent. That's where the stuff is put at. In most cases, what I've seen over the past week is people were just stuffing Log4j commands in anything. I saw an LDAP one where they were putting it in any form that they can get their hands on. They were just stuffing this stuff everywhere. So make sure to look for this, and I'll be showing you some proper rules. But so far, this is what it looks at. This is what it looks like. We can request pickup from here, which is also really great. And then you can look at it pickup later. But so far, from just a single scan on the network, we can see who initiated the conversation here. and the whole TCP handshake. And you can even dig into this pickup if you download it using Wireshark, which will be really nice. But for now, let's move on to the actual attack. So you now know an attacker can scan your network using publicly available scanners. And I just showed you an example of one of them, which in this case, it didn't show me much. So now that brings us to our vCenter. It's public knowledge that VMware vCenter is vulnerable to Log4j or Log4shell vulnerability. And right now, this is vCenter 6.7. I also did the same on vCenter 7. And both the appliance and the one on Windows are vulnerable. So if you want to watch the exploitation of the one in the appliance, the Linux appliance, you can check out my other video on this channel. Otherwise, this one is in Windows. And you might be wondering, well, why would you attack Windows? It's fun to get reverse shell in Windows than in Linux. I find it challenging to get reverse shells in Windows, and it's also satisfying to get reverse shell. So that's why it's just mostly because of the why. So how do we exploit vSphere, vCenter? If you go to the internet, you know there is a proof of concept. I used that proof of concept. At first, I didn't know what I was looking at because it wasn't a full step-by-step proof of concept. They just gave us 2 screenshots. So I had figured out. And lucky for you, you get to see it right now. And hopefully you use it for good. The part that's vulnerable is this right here. So in a nutshell, when you sign in and you say, hey, administrator, and then password, you can use a local LDAP server for authentication, just like using Active Directory or another service to authenticate people. You can use that for authentication, and you can use single sign-on as well if you're part of an Active Directory environment. And that's the part that is vulnerable. I mean, that's the part that we use. That's the part that we can use to get to the Java application that's running on the system. All right. So now that we got that, we need this URL here. And we know from this URL that it's vsphere.local. This last part here, that's a domain that we're authenticating to. Sometimes it might be different. This one, I set it up to just report to vsphere.local, which might be most default installs out there. Once you know that, we need an LDAP server. We need to trick this sign-in page here to check in to our LDAP server. So instead of going to a legitimate LDAP server, we're saying, no, come to our LDAP server and we will give you the credentials for the person to sign in. And during that process, we don't give it credentials. We give it our reverse shell. We give it a fun command to run. And that's all there is here. It's actually not that complicated. All right, now that we have that out of the way, let's go ahead and exploit this. First, you're going to need the LDAP server. You are like, oh, how do I get an LDAP server? Let me find one for you. This one is known on the internet. There's a bunch of them, especially over the past few days. This one is called Rogue JNDI because it really is rogue. It's simple to use and it gives you the usage here. So what you want to do, git clone this repository. And since we're talking about attacking, I'm assuming when I say git clone, it's kind of easy to understand. But clone this repository, set it up by just running Maven package. And once you run Maven package from that directory, this will just be set up for you. It's very simple. And if you don't have Maven, you can just literally go to Google and say, hey, how do I install Maven on Kali? And if you see instructions for Ubuntu, there you go. You can just install that. So install Maven. And I just put some instructions here. These are not the ones that I used. I used something similar, but they might work for you. Then once you install Maven and you run Maven package, all you have to do is from within the same directory where you cloned the repository, run this command here. So we are going to weaponize it right now. Let's have it do something less malicious. So here's the command from the Git repository, and I'll explain what we are doing here. The last IP address, this is going to be your IP address of your Kali Linux. So let's find out what our IP address is here. So it's 0.38.171. So we need to put 171 here. All right. Then instead of looking up a server, why don't we do a ping? All right. That's all we have to do. It's very, very simple. Like any script kiddie who can follow a few steps instructions out there can do this. So what is happening here? We are going to set up an LDAP server. It's not doing anything right now, but this LDAP server sets up an HTTP server here, and it listens on 1389 on LDAP. Right now, it's waiting for someone to reach out and say, hey, can I query you for LDAP request? And since this is a malicious LDAP server, when they reach out, instead of responding to their LDAP request, we actually inject this command here. And in VMware, this command here will be in the logs file, and that's how it's executed. So right now we're just listening on the LDAP server. When we now need to ask this server here to reach out to that LDAP server and say, hey, can I get this user? And once that server reaches out to this LDAP server, we run the command. All right. But before we run the command, let me do something interesting here. Let me listen with TCP dump so that we can know when the ping comes back. So give me 1 second. So right now what I'm doing is I'm saying, hey, TCP dump, can you listen on if0? If you see any ICMP packets, let me know. And who is going to send ICMP packets? This command here. So if VCenter reaches out to this LDAP server and this command is ran, I should see ICMP packets responses here. That's all there is. All right. So once we do that, let's force our vCenter to actually respond. When you read the proof of concept out there, you can run curl or you can send this using burp suite. It doesn't matter. But we're saying here, running the curl command, we want it to be insecure. I don't have certificates here. I really want it to be verbose, double V. And in the header of my request, I would like to use the X forwarder 4. That's the part that's vulnerable for vCenter. And I'm saying, hey, here's the classic Log4j payload. If you have not seen this part here, it's almost the same for most of them. I'm saying you call it by using JNDI. Then you say, hey, LDAP, can we reach out to this server, which is the one that's listening here, on port 1389, which is right here. We're just listening on for everybody this time. And we're using the Tomcat. This is the one that calls for Java libraries. There's a few options on the Rogue and JNDI server. This is the one that works for us. Then we go to our vCenter. It's HTTPS because vCenter only responds to HTTPS. And then the IP address, web sign-on, and then we need to make sure that it's vsphere.local. By sending this, it will reach out to here. Now you notice we now have the payload here. These words here were not there when this was sent. And if this worked, this is just proving that we can reach out to vCenter and make it run commands. We should see ping responses right here. So now we have ICMP responses. We're just testing the waters, right? We're finding out, okay, so this thing responds to ping. I wonder what else I can have it do in order for this to actually work. So it responded to our ICMP, and sure enough, it ran the ping command, which is right here. Or I don't like just that we just ran a ping command, but that was a really good proof of concept before I went too deep. What if I just weaponized this? What if we changed this command here and use tools like Nishang, for example, to get a reverse shell? Or what if we transferred a payload like MSF Venom and generate a reverse shell payload, or run some PowerShell commands there? So right now, as an attacker, this is a blank canvas for me. Right here, between these quotes, I can put whatever I want. And of course, I do have some interesting payloads to put there, and I'm very excited to be putting them there. So let's actually create a payload here. So I'm going to bring up a text editor, if I can. Oh, it doesn't want to. Okay, let's go to my OneNote here. I'll just create a random page. And then taking our blank canvas here, let's construct something more interesting. Because I would like now to get a reverse shell from that system. And everything I need to do is going to be in here. So first, what I can do is I can just upload netcat to that system and see if that works. So let me go to my file transfer section. To upload something to that system, I'm going to use setutil. My notes, I've been building these for a few years now. They're all over the place. Please don't judge me. They work for me, but they're like not organized in any way. I know where to go though, because it's my mess. So here's a bunch of notes. If I want to move files between Kali Linux and my victim, I have a few ways. I can use PowerShell, I can use SMB, I can use setutil. Setutil is easy to use because it's living off the land. I can also use wget if I wanted to, but setutil in Windows is, it's pretty much there, so why not use it? And for the most part, people ignore it if it fires. So let's go here and say, oh, we would like it to run setutil. And what this is going to do here, let me put this one to netcat. It's going to reach out to my Kali Linux and download netcat. So 192.168.38.171. Okay, so it's going to say, hey, setutil, go to this IP address, get me netcat, move it to the C Windows. I like in the temp, anyone can write in temp, so why not put it there? So let's put netcat.exe. Okay, so this part here is what's going to download netcat.exe. Why do we want netcat? Before we run that, well, if you want to get reverse shells, for those who might ask for my notes, these hack tricks notes are the best. I actually borrow from here once in a while. This is what we want to do. This is the first phase is we need to get netcat there. Second phase, we need to run this command here. That's why we want to put netcat there. All right. So now that this command is constructed, let's go and put it in Kali and do it again. So we would rehost our server again, but this time we're running setutil and we want it to download netcat. In order for it to download netcat, we need to make sure we don't need this one anymore. We need to make sure that we have netcat. On my Kali here, I have netcat everywhere, but your Kali Linux should have this directory here. The user share Windows resources binaries. This is the most trusted binary for netcat. You want this one. You don't want to be messing around with other corrupted binaries. So this is the one that I will be using. And to do that, I'll just do a copy. and then I'll put a dot, and now I have netcat here. Let's host a server on 80. This is now saying, hey, I'm hosting a server on 80 for anybody to reach out. And if someone reaches out and say, I need netcat, we'll give them. If they reach out needing anything in this directory, they can get it. So this is an HTTP server. Our HTTP server is ready. LDAP server is ready. Now we need to go back and fire. This is the fun part. It's like setting it up. We now know what this is doing. So this time, we're just reaching out so that we can download netcat to the temp directory in Windows. Okay? Time to fire. So it worked. The one way to know that it worked, we check the payload. We now see that it did deliver. We also have to go back to our HTTP server. I have no idea why this thing does this. Look how many times it reached out back to me. That's how many times we have executed this. So if an attacker wants to deliver anything to your system, they can use this method here. And this time we only deliver netcat. Let me see if we can. Let me see if I can show you where this netcat is in Windows. Because we need to make sure that it made it there. So here's a Windows server. I might need to mess with it a little bit. It's okay. There we go. Let's go to the directory. Where did we say we wanted netcat to be delivered? We wanted it to be in the C Windows temp directory. So we go to Windows. Then we need to find the temp somewhere. I didn't prepare for this one. It needs to be in there. But as an attacker, you won't know that this actually happened. But look, we have netcat. I have to let you in on a simple secret though. In order for an attacker to deliver these binaries to your Windows, Windows Defender has to be off. If Windows Defender is out, hanging out and doing its job, it will remove any executables that are delivered. That will not prevent attackers from getting executables to your system though, because they can get them there encoded using other methods. But just full disclosure, what I just did here will get cleaned up by Windows Defender as fast as it gets there. But we did get netcat to the system. So now we need to move on to the next phase. After we get netcat, we can get a reverse shell by running this command here. So we now need to change this to give us a reverse shell. So I'm going to keep this part here. You know why. All right. So I'm going to keep the part that says C Windows because I'm giving it an absolute path to where the executable is. Then I'm saying now let's run the rest of it. This is how we're going to get a reverse shell. And if you're not familiar with the reverse shells, I do show this every week, every Sunday at 9 p.m. Central Standard Time. I show how to get reverse shells in Linux and Windows. So that is our IP address. Then our port. Let's put an interesting port here. What port number can I pick? Let me just do. Oh, no. Maybe 4. Let's leave it at 4 6s, not 3. That way we're safe. All right, so now what we just did here, we're saying, hey, this time run netcat on Windows by giving it its full absolute path. What kind of noise is that? And execute, reach out to this remote IP address on port 666. So what do we need to do? We need to run that. And this time, we need to be listening on port 666. So we stop that and say netcat, listen verbose to a numeric port of 666. If Windows Firewall is enabled, there is an easy way to bypass it. You look at open ports on that system and you listen on a port that is open on that system. That's what you do. So I don't know if I disabled Windows Firewall. If it doesn't work, I'll actually change this port to something like 443 or 21, ports that might be open on Windows. So we're listening. The kernel is loaded. We haven't delivered the payload. So now let's deliver the payload. If it doesn't work, we're in this together. You need to help me get it figured out. All right, so we're going to rerun, reach out again. We check to make sure that it did run. We see payloads here. And it didn't work. What could have happened? I told you, we're in this together. So let's leave that on 666. Let's go back here. My first suspect is my command. C Windows temp naked. Oh, what am I doing? Where did this E come from? That's why it didn't work. I had an extra character in there. All right, let's load it again. Verify the payload was delivered. And nothing. All right, this happens all the time. It doesn't matter how much I try to get ready. Let's change my port to something that I know, 443. That way, we know that we do get a reverse shell. This is what I was saying. If Windows Firewall is enabled, Windows will tell you to go £send if you try to get a reverse shell. So we need to make sure that we actually use an open port. So let me rerun that with 443 instead. Let's cancel. We haven't done any detection yet. We'll be looking at that very soon, but we need to know what we did. All right, give me 1 second. Let me get my command here. All right, so this time we're running the same netcat command, but it's going to 443 because Because 443 is allowed on Windows. Because Windows Firewall, I think, is messing with us. But we can bypass it. All right, so that is working. We just need to change our listener to .443. Then we fire it again. If we do it this time and it doesn't work, I might have to figure out why. But this should work. Payload has been delivered. And we are in. Isn't it funny how attacking things work? I've attacked more than 100 machines, if not more than that. So I know when my reverse shells don't come back, there's a few things that can break, and one of them is with Windows, ports. Ports will haunt you. Ports will haunt you. Okay, so who are we? Oh my Lord. We are in as NT authority. It doesn't get any better than this. So what this means is we have full control of this VMware VCenter server, and we can do pretty much what we want here. You can try to see if you can do lateral movements as administrator, you can steal people's password hashes. There's so many bad things that can happen from being NT authority on a system, especially if this is a domain joined machine. So I've shown you how we can compromise vCenter, end up in the system without even knowing a password by just having access to it. What is the significance of this? If you run VMware vCenter and it's in Windows or Linux and it's exposed to the internet, you need to update that as soon as possible. There's a workaround that you need to apply. It's all over the internet. It's very easy to apply. Make sure to do so, because people getting NT authority on your system, not so cool, right? Especially when they don't even know what they're doing. Right now, we don't even know what we just did. Most of you watching are like, oh, what just happened? You can follow along with this video and you'll be NT authority on your system. So this is really not ideal, right? So what we need to do now is figure out, how has the community responded? How can we detect this? If you're running VMware vCenter and you have endpoint protection, like, what could you see? So let's take that, let's flip the script. Let's go to our intrusion detection system here. First, I'll go to the alerts section. I'll show you what the alerts look like when you do something funny like this. You see, this is from right now. A few things were fired. These alerts, I had to set them up, so you need to know not only that they get run, but what are we looking for when we are running these alerts? Or first of all, this one is the most interesting one. Potential Java JNDI exploit attempt. Well, how did we know that it was a Java JNDI exploit attempt? So if you go to Elastic SIEM, they do have a rule. This applies to any SIEMs that you have out there. They have rules. So before I show you all that rule, I'd like to break this thing down here for us. It's very easy. It's not intimidating at all. Just know, this is the format that Elastic SIEM takes rules. It's just like Yara rules that we were talking about 2 days ago. When you're talking about Yara, all the rules are in the same format, right? Okay, so this is a correlation rule. We're saying, hey, by the way, if you see a process called Java, I had to modify this to say java.exe in Windows so that it actually works. And if this is just a comment, if it's going out to an LDAP server or any DNS server, this time we were looking for 5353 for DNS, and I think these are for LDAP. Don't know what this one is. So if we see Java, and Java initiates an LDAP connection and is starting a process, that is interesting. So we're not just looking for one thing here. We're saying, if a system spawns Java, starts a process, initiates a connection to a particular server, and we see a child process, make sure that we alert. So as far as the child processes are concerned in Windows, this did not work for me, because as you can see from my attack, I did not execute any of these here. My Java did not start, curl, Python, Ruby, PHP, or even wget. I avoided all of these. So what you can do, if you have a Windows environment, you can expand upon this by adding setutil.exe here, netcat on this list here. Then your detection will work. Otherwise, if you use this rule the way it is, it will not work. But just know that if we see an event that says connection was attempted and it was started by Java going to a port, and on the same system we also start a child process, we will alert. Why is this the case? Why do we care about Java and LDAP? This is the Log4j vulnerability. This is how it works. It uses a Java library to make sure that it reaches out to external DNS and LDAP servers. And once it does that, it will start other processes to run commands, to do funny things. That's why this rule is there. And like I said, that rule will not fire for Windows. So what rule do I have that fired? Let's find out here. So first, let me just filter by this. So by just clicking that plus, I'd like to show you the rule that fired. Then we can really dig deeper into the packets and look at, how can we really interact with this data even more to get more intel about it. All right, so far, this is the rule that fired. I'm going to expand on it. All right. I'm going to view the rule on the detail here. And I think, yeah, there we go. So it's an event correlation rule. I removed everything after here because I wasn't getting anything. And I know why, because I wasn't spawning any of these child processes. Now, if you want to be better than me, you need to add setutil, PowerShell, and all the interesting Windows stuff here. But the same rule applies. I changed it to run every minute because I wanted it to really trigger as often as I can. And then, yes, I agree with Mohammed there. I'm looking for the same, but also notice I said java.exe because it's Windows. This rule is here. This rule here is looking for Java. So without that exe, it's not going to fire. Then, of course, I left that there. But we need to make sure that there is more. Understanding these rules and how they work is going to be really, really important for us. So far, we know what rule we have. Let's go and look at the data that we get from this rule here. We can get this data both on the network as data is moving across the network, or we can get this data from the endpoint itself. It will tell us what happened. So I can make a query here directly in our Elastic database. I would like to see that data. We're going to see that from a tool called Zeek, or also formerly known as Bro. And it's going to show us the connection. Okay, what happened, and can we see a broken event? This thing doesn't seem to be loading. Someone is causing it. Let's see. This is a trial version for mine, and there's no credit card here. So, all right. So while the cloud works on loading, I can also go to a local copy here. We can use Kibana querying language, which is very important to know because it's the same as other querying languages out there. Let's actually use Security Onion here because that one is taking forever. So in Security Onion, I can also look for any data that might be interesting for me. Let me see. Let's just look for the destination port. Port of 1389. Well, we know the behavior of our system, right? So here, Zeek is going to show us, hey, across the network, I saw people reaching out to this port here so many times. In a production environment, if you use LDAP, there will be a ton of traffic here. So you need to really specify, source IP address if you are doing the hunting here. But for now, let's look at the traffic. Okay, so this one that we saw in Security Onion was just coming from our Docker instance when we were doing the scan. I know this because I saw a Docker IP address here. But we're scanning that server there. And in the message, this is what it looks like. And this is a Zeek Con event. It's not as exciting as it should be. Suricata events are usually exciting, but this is just a normal SYNFIN completion. Just confirming how many times. We can see how many times our host, in this case, has reached out to the LDAP server. And you can confirm, oh, they probably ran the commands this many times here. And that's how many times I actually ran the LDAP server. So let's go here. Take it further. Let's query our endpoint data. That was network data as it was moving. Let's reach out to the endpoint data. And I just have this already done. This is exactly what we used for the rule. What are we looking for here? We're saying, hey, if you see an event action that says a connection was attempted, was someone is trying to reach out somewhere, and it was started by Java, and the destination port was this one, and the event type was start because we started a process. Let me know where you see that. This, oh, I refreshed. It's almost identical. The interesting thing here is both on the network, as data was moving across the wire, and on the host, we're getting identical data points. Oh, this is not cool. All right, I'll let it load again. But notice the behavior of this. We have this long, two short ones, and then these two at the end here. It's almost the same that you see in the cloud, in Elastic SIEM, when you go there. So that was the first one. I'll show you the graph once it loads here. Other detection indicators, in this case, we did get a reverse shell, and we ran Who Am I, and we did all kinds of funny stuff. So Elastic SIEM is going to show us all the alerts that fired. So let's go to the alerts. And look at, I don't know if you can see this. Yeah. But I hope you can see. Let me see what you can see here. I hope you can see. Right here it says suspicious set-util commands. So you will not see this if your attackers are smart. They will base64 encode this stuff. You will not see it because they'll base64 then decode it later. Maybe you'll be able to see it. Actually, you might be able to see it since this is host-based. You won't be able to see this from the network side unless if you're decoding base64 as well. Or if this is, in this case, Security Onion is unable to see set-util commands here because we attacked a server with SSL. So that's why. But it saw a suspicious set-util command, the one that we just ran. It also saw that we ran Who Am I process here, which is also very interesting. And you already know what we did there. Look at how many of this stuff we triggered. Let's look at the suspicious set-util. Then we can look at what it's actually looking for. All right. So if you look here, it's looking for, here is our actual command that we ran here. What happened here? All right, here's our actual set-util command. So in hindsight, well, I actually wanted you to see this, but in hindsight, if you do not want this to be seen, the payload that we delivered just needs to be encoded. And if you encode it, then decode it later, I'm curious what that will look like on the endpoint section. So this is a learning point for me. If anybody knows who is watching right now, if I had encoded these set-util commands in the Who Am I commands, and I'm doing endpoint detection, could I still have seen it after it was decoded and ran? I should be able to see it because the command did run and we're logging. But so far, this is, of course, us getting netcat. And as defenders, you see netcat being run. What do you think is happening? Who has business of putting netcat on a network, trying to get reverse shells? Or why would somebody be moving netcat using set-util in your network? So we need to figure that one out. So instead of a medium, I'll put this to be high. What does the rule look like? I like to see, okay, what are we looking for? Because that's actually interesting. So we are looking for a process, that's process type. When it starts in the process name, they're actually looking for setutil by name. So setutil, because it's living off the land and it's default in Windows, it's already out there. It's also looking for the encode and decode. So we would have caught it anyway. That is awesome. This is just amazing. Just looking at these rules here. So this rule we have found setutil whether we have encoded or not. All right. So that was one. Let's go back to our alerts. We did see that we have a who am I command that was also ran. So let's just filter by that traffic. Okay, so we did run the command who am I, and by doing that, it calls the executable who am I, and it's low. The severity says it's low here because running who am I is not really malicious, but who runs who am I except the person who signed in through the back door? People who use back doors are the ones who ask for directions, right? So it's just saying, hey, by the way, I saw who am I in command, and that's what happened here, which is also really great. So that is just the host-based detection right now. On the network, which I didn't spend a lot of time, but we should have, I was expecting Security Onion to detect, and I'll tell you why we don't see a lot of alerts in here over the past 4 hours. We don't see a lot of alerts, even though Security Onion does have Suricata alerts. I believe it's because of this. When we were here, we are reaching out to an HTTPS server. Even though I specify that I want this to be insecure, I'm reaching out to this HTTPS server here. Somehow, this is my theory, correct me if I'm wrong, because I'm really learning about this stuff. And I was curious why it didn't run, even though it's HTTPS. It's probably because it thinks that this is encrypted traffic. I don't know why it didn't actually trigger, but I thought it's because I'm using HTTPS, even though I don't have valid certificates. By using HTTPS, I crippled my Security Onion from seeing anything. I don't have any SSL decryptors, so I didn't see anything. And if you run it with just HTTP, it fails. And it fails so much so that it doesn't even reach out over the network. It just fails. And with that, I don't even see the traffic moving to my victim machine. But I wanted to bring your attention to Suricata rules, because we do have rules that are meant to detect Log4j. If I look in all rules here, let's just do that and grab Log4j. This might not be the smartest way to view this, but we do have a ton of them. I do have Suricata rules that are deployed over the network that are looking at a bunch of things related to Log4j. So you should still be able to see it if you're able to decrypt your SSL traffic. But so far in my lab environment here, without any fancy things, endpoint detection was the best so far. But I truly believe that using all these rules that you see here, there's a lot. I mean, there's a ton. You can actually run it. And if you followed my video and you're like, wait, hey, how do I get the latest rules? If you do crontab -e in your Security Onion, there is actually a rule updater somewhere in here. It's somewhere in here. There's a cron job that will update your rules. And you probably have the rules. But if you're unsure, you can just run this command here. And this will actually update your rules. Oh, why did he say that? Okay, it's so rule update. So you can update your Suricata rules and you'll be able to actually see things as they traverse through your network as well, and you get the latest rules. So that's part of detection. Then you can always, as always, I really like to just interact with your data. Know the data that you have, right? So if we go to here, let's interact more with our data and see what else can we find. I think I already did this, but I'll repeat it again. Do not do this in a big environment. If you have terabytes and terabytes of data, this will lock your database probably. But I'm saying, hey, if you see in the HTTP URI the word JNDI or any of those stuff, you can actually come here and see, oh, who was running anything JNDI related and when. You can see this is my scanner here when I was scanning my network, and it's the same stuff, just looking for JNDI. So I highly encourage you to spend some time, practice, play with this data if you can. It's really, really fun. It's another thing to hear people talk about it and spend 40 minutes explaining what Java and how it works and who is affected and what, and make it all, sound glamorous. It's another to come and actually execute these commands, see the data, interact with the packets, see it in Wireshark. It's a whole different experience, and I hope that this just acts as a motivation for you to start your own home lab. I have 12 videos that will show you how to set up your lab if you need to. I'm also available if you start setting up your lab. Just let me know. I'll be able to probably help you set it up. I'm going to be having more live streams starting in a couple weeks here, where we just focus on setting up labs so that we can do things like this. So I really, really appreciate everyone who is here and who watched. And right now, I'll leave this time to questions. If you have any questions, or if there's something that you want me to do, please let me know right now, and then we can try it. Otherwise, I'm just going to look through some of these comments here as well. Looks like somebody was trying to spam us, but that's fine. And yes, hands on, that's where the money is at. I don't care how many certifications you have. If you have never run a lab and you're just brain dumping certifications, it doesn't help. And thanks, CyberTech Dev. Really appreciate you being here. It's such an honor having everybody here. This stream was attended by a lot of people, and it's just amazing to see people. Thanks for joining. We do this on Sundays at 9 p.m. Central Standard Time. I will not have the stream this coming Sunday because of the holidays, but the Sunday after that, we will come back here. We're going to be doing a lot of Active Directory exploitation, learning really how to get into Windows systems, get the exploitation and detection in place, especially endpoint detection and network-based detection as well. It's awesome. Yes, I think I did set up an Active Directory in my lab, so you should check that one out. Awesome. All right. Looks like we don't have a lot of questions. Thank you all for being here. I really appreciate people joining. If you like this, please make sure to like and subscribe. It would be nice if we can reach 30,000 subscribers. This channel has grown. I didn't think people were interested in this stuff. I thought this industry was such a niche. But as you can see, people do like security and detection, and that's going to be something that we will do a lot more of. Are there Elastic Docker containers? Yes. Yes. Let me show you how to set it up. I have a on my GitHub. I actually do have a. Let me show you. I have Elastic containers that you can run that will give you everything that we have here. So here, if you want to run the SIEM solution locally and you don't want to use the cloud one, I do have an Ansible Playbook. This is from a few months ago, so you might want to update this. This is from 17 months ago, so there might have been changes, but you can cannibalize on this Ansible Playbooks here, and I even have a video that will show you how to do it. I was doing it in Ubuntu, and yeah, you can use Ansible for this. I think I also have another one. Okay, I also have this Docker Suricata. This one, yeah, this one is the one that I was talking about. This is the latest one. This is a Docker Compose file. It will run the SIEM for you. I forked this repository somewhere, but I do have a Docker Compose here that you can run, and it will give you everything that you need. This one doesn't have Ansible. The other one had Ansible, but if you're interested in setting your own SIEM solution, here it is. And in this one, actually, I added Suricata. I think that's what I did. That was a month ago. So this one is going to give you that. Then, of course, you need to change these passwords and look through this. This one will also give you Suricata host-based intrusion detection on the same system, which is not native to that. Then you can enable the Suricata module on the other end, which is kind of fun. So I do have the SIEM here. All right. This is amazing stuff. I mean, I've never been so excited about just things that I do to get paid. I also get paid to do this stuff, but just learning about cybersecurity and doing things, seeing things actually work is amazing. So if you do like this, I encourage you to like and subscribe. There's going to be a lot more fun stuff coming. And if you missed the whole stream, please watch from the beginning. We did get a reverse shell on our Windows system, and we also showed you the rule that detected it, and also how detection actually works for this one. Oh, yeah. That I did look at the other SIEMs. I really wanted so bad. I was so desperate. I wanted to attack Elasticsearch, and Elasticsearch, the engine itself, is not vulnerable to remote code execution. So I really wanted to make sure that I attack Elasticsearch if I could. But of course, it's not vulnerable. But Elasticsearch was my #1 target. And then when it didn't work, VCenter became the next victim. Mostly because I've worked with these tools before. I've deployed Elasticsearch. I've deployed vCenter. So I kind of have an idea of how things go with those tools. But yeah, it'll be interesting to see. Next, maybe we can do another one where we can pick on another vendor once they have patches out there. And thank you, Matthew. I hope that one includes the SIEM solution as well. But if you missed it, please make sure to watch. Set up a free trial on the Elastic website. It's very, very easy to set up. And I think, yeah, it's 10 times easier on the cloud. So if you can, go to Elastic. They don't ask for your credit card. It's just an email address and a password, and you're in. So you can set one up, try it out. 7 days is plenty, and if you need more time, they'll even give you more. Then set up the Elastic agent, point it there, and start attacking. It's best used in Windows. In Linux, it also works, but Windows is very, very interesting to look at. So highly encourage you to do so. And if you have any questions, please let me know. Otherwise, thank you for being here, and I'll see you next time.